Welcome back to Aurora Tech Channel. Today, I will review the BambuLab A1, which is essentially a larger version of the A1 Mini. I reviewed the A1 Mini 2 months ago and awarded 2 titles to it: the most advanced mini 3D printer and the best value mini 3D printer. Honestly, there's not much competition in the mini category, but this time, the A1 will be entering the most competitive category, the regular size 3D printer market. The price is pretty aggressive considering the hardware. It's $399 for the machine without the AMS Lite, and it's just $100 more than the A1 Mini. It doesn't sound like a budget printer, but it's definitely putting a lot of pressure on other budget printers in the sub $300 price range. If you purchase the AMS Lite for multiple color printing, it will cost you another $160 for a total of $559. So, let's take a look at what we can get from this machine. The print volume is a 256mm³, which is the same as the X1 and the P1 series. The firmware is their own, and at first, I thought it was another Clipper variant, but BambuLab spent a lot of time explaining how their firmware is different, and the part that actually convinced me is that Clipper firmware runs on Linux, so it requires an application processor like a Cortex A53 quad-core 1.5 GHz, like the one you see on the MKS Pi, or a processor that is at least running at 1 or 1.2 GHz, like the Raspberry Pi Zero. But in contrast, this machine has no application processor. It just runs on 3 MCUs, so let's take a look at their motherboard. It has an ESP32 and a 32-bit Cortex M4 200MHz dual-core chip. The other single-core 32-bit chip is inside the print head. So, this setup has no way to install Linux OS and run Python and Clipper. So mainly for this reason, I will call this their own firmware instead of another Clipper variant. Like the A1 Mini, it has the same input shaping, or as they call it, vibration calibration, and their own motor noise cancelling feature. It fully automatically calibrates itself, including the auto-Z offset, auto-bed leveling, and flow rate compensation using an eddy current to measure the pressure inside the nozzle. Besides that, it also features a low frame rate 1080p camera, a filament sensor, a filament odometer, and a filament tangle sensor. It comes with a stainless steel nozzle that can reach up to 300 degrees Celsius. The print bed has no knobs underneath, so it will solely rely on the leveling sensor for bed leveling. The magnetic bed is a high-quality one, unlike those magnetic sticker beds, but the maximum temperature of the bed is only 80 degrees Celsius, so you may not be able to print ABS, ASA, or polycarbonate, which requires an 100 degrees Celsius or higher temperature heated bed. For the AMS Lite, it's more like a rack to control the movement of the filament spools in order to feed in and retract filament from the nozzle. It supports printing up to 4 spools at a time. Anyways, $399 for the machine or $559 with the AMS Lite looks pretty promising. I would like to thank BambuLab for sending us this machine to review, and I would also like to thank VOXELPLA for sponsoring today's video. VOXELPLA is a brand created by a print farm in Southern California, where they exclusively use their own filament with over 150 3D printers that are operated 24/7 non-stop. This extensive testing leads to high quality and reliability in their filaments. VOXELPLA Pro is a modified version of PLA that provides higher impact strength and supports high-speed printing of up to 500 mm/s while maintaining a flow rate of up to 25 mm³ per second at a regular printing temperature of 210 degrees Celsius. VOXELPLA Pro is also affordable at just $16.99 for a 1 kilogram roll. Ordering 3 rolls comes with free shipping, and bulk discounts are available starting from 6 rolls. They have recently launched new filament colors, as well as the Vision Enclosure Kit that includes all the necessary parts to fully enclose your BambuLab P1P. For more information, please visit voxelpla.com. The box that BambuLab sent me has the A1 and the AMS Lite. The packaging is similar to the A1 Mini, like how the machine is surrounded by custom laser-cut foam. At first, I thought it was also one piece like the A1 Mini, but it seems the gantry and base are separate and we need to do some basic assembly. Besides the base and the gantry, we have the AMS Lite, some boating tubes to work as a filament guide, a filament holder, a double-sided print surface, a power cord, some tools, a set of color swatches of their filament, and a DIY jet engine model just for fun. First, we need to remove 4 screws under the base to unlock the Y-axis, then we can slide it back and let it sit on top of the gantry. To secure them, we need to remove the cover of the base. There are screw holes labeled in green, and we need to tighten all of them. And there are 2 more that need to be tightened from the front. After that, put the cover back, flip it over, and connect some cables under the base. Just follow the colors, and there's not much you can go wrong with. The Z-axis motor has to run through the cable clip like this. Then, install the print head wiper at the left side of the gantry and mount the filament holder on top. Okay, we can now turn on the printer. Select language, location, and I will connect this printer to my Wi-Fi network. Just select the SSID and enter password. Then a QR code shows up. As I already have a few different BambuLab machines, I will just use my phone to scan it and connect this printer to my BambuLab account. Okay, it will now start input shaper and motor noise cancellation. It will move the X and Y axis at different speeds from 50 mm per second to 300 mm per second for noise cancellation. I can hear some difference with noise cancellation off and on. It is slightly quieter. Then, it's going to calibrate the input shaper. The difference between the A1 and other Clipper machines is that most machines will test from 0 to 200 Hz or less, but this A1 tests all the way to 500 Hz. After a few minutes, it's done. The first thing that pops up is a firmware update. As this is a new machine, I will just let it update to the latest firmware before starting the test. Okay, let's load some filament. I will start with Fire Engine Red VOXELPLA Pro. As this is not BambuLab filament, there is no RFID on the spool, but we can just manually enter the filament type and color with a few clicks. Okay, the red filament is coming out. So, I will start with the 90-minute Benchy that came with the printer and see how well it can print at a high speed. It starts with doing a short version of input shaper calibration, which takes around 15 seconds. Then, the print head moves to the back of the print bed to clean the nozzle. It's now pushing itself down on the print surface and cooling down the nozzle to around 140 degrees Celsius for bed leveling. As this is our first print, I also selected to enable auto bed leveling. It's going to do a 7x7 49-point probe. The leveling is pretty fast. It took around 10 seconds per row, so it's a little over 1 minute for the whole process. The first layer is printing very aggressively. I can hear some Z sounds, and it seems that they're coming from the print head wiper at the left side of the gantry. I will let it finish the first few layers and test the sound level. I place the sound meter 6 inches away, and the sound level is in the high 50s to 60 decibels. The fan is still the loudest sound, as the rapid movements from the X and Y axis don't increase the sound level at all. The Benchy finishes in 19 minutes, and the print quality is pretty nice. I can't see any obvious ringing on the surface. The layer is clean, and the cooling at the front is also good. There's another 21-minute Benchy, so I will also print that. But as far as I can see, they both look like a 0.25mm layer height, and the 2-minute time difference doesn't have much of an impact. Maybe the stringing of the 21-minute one is slightly better, but other than that, the surface, cooling, and layers are basically identical. Then, I will run through my usual tests real quick, starting with the Honeycomb box retraction test using Fire Engine Red VOXELPLA Pro. Extruding a tiny bit of filament and retracting it immediately can be challenging, but as this extruder is the same as the A1 Mini, I think they both handle this part really well. The print finishes in 2 hours and 16 minutes. So it's not the fastest, but the print quality is one of the best. Let's compare with other printers. I think it may not only be one of the best, it's actually in the top 5 or even the top 3. Let's take a closer look at it when it's compared to other BambuLab machines. It's identical to the A1 Mini. The pattern of the X1C is printed slightly differently as it's not using the same extruder, and I printed this a while ago. Personally, I do like the A1 and A1 Mini more. Next, I will do a clearance test and print the number slider with yellow VOXELPLA Pro. The first layer looks good, and all tiles have gaps between them, so the Auto Z offset is doing a pretty good job. The print finishes in 2 hours and 51 minutes. It's slightly slower than the average 2 hours and 45-minute time, but again, the print quality is awesome, the top is nice, there's no stringing at all, and the bottom was printed nicely. The clearance is also very good. Then, I will do a tolerance test by printing my own testing model with Fire Engine Red VOXELPLA Pro. It finishes in less than 2 hours, so surprisingly, it's faster than the average 2.5 to 3 hour time. It can clear all the way from 0.225 to 0.1, but when trying 0.75, it was too tight. For the cylinder, it can clear all the way from 0.225 to 0.05. I think the square didn't do as good as the cylinder, mainly because of the overshot corners. Even though I enabled the flow calibration, the overshot corner doesn't seem to be significantly improved, so maybe more tweaking is required for the firmware. Up next, I will print a decorative print, the Robo Alpaka from Prusa. The print finishes in 5 hours and 37 minutes. The print quality is alright, but the print speed is one of the slowest among all new generation printers. Let's compare the result with other machines. Compared with the fastest bed slinger, the Anycubic Cobra 2 Pro, the Cobra 2 Pro is much faster, but the A1 print quality is slightly better. Compared to the second fastest machine, the FlashForge 5M Pro, the print quality is similar, but the FlashForge is much faster. Compared with the BambuLab P1P, the P1P is faster and the print quality is also better. Let's compare with some slower printers, starting with the second slowest one, the AnchorMake 5MC, for which the A1 is a clear winner for both print speed and quality. Finally, let's compare it to the slowest new generation printer, the Prusa MK4, which runs its own version of Marlin. The print quality of the MK4 is the best among all machines, but the speed is also the slowest. Let's try some other materials, starting with TPU. I will print a simple wallet with 2 walls, 3 bottoms, 0 top and 0 infill. The default profile limited the TPU flow rate to 3.2 mm³ per second, which is just around a 40 mm per second print speed. Since Eryone TPU can normally print faster, I will set it to 5 mm³ per second, which will equal to a 62.5 mm per second print speed, just like how I test other printers. The print finished in 1 hour and 12 minutes. The extrusion is perfect, and the transparent look of this blue TPU is really nice. As the maximum temperature of the bed is only 80 degrees Celsius, I won't print ABS or anything that requires a bed temperature higher than 80 degrees Celsius, but I will still try to print some PETG. The default profile is set to 70 degrees Celsius, which is lower than my normal bed temperature of 85 degrees Celsius for PETG, but I will just set it to the maximum 80 degrees Celsius. For the volumetric speed, I will set it to 12, which is equal to 150 mm per second. The bottom and the wall seem to be printing fine, but when printing infill, they didn't stick together perfectly. When I go back to check the slicer profile, the cooling is set to 40 to 90%. It could be better if the cooling is set a bit lower, but I will just let it finish. The surface of the penholder looks good. It seems the slightly imperfect infill doesn't have much impact on this print overall. There is a tiny bit of stringing inside, but it still looks pretty cool with some lights, and the bottom is also printed nicely. Before I test out the AMS Lite, I would like to print a mount from BambuLab, which allows you to mount the AMS on top instead of occupying that much table space. I will just print this model using gray VOXELPLA Pro, which matches the color of this printer. The print finishes in 6.5 hours, and since I just used the 3MF file directly from BambuLab, the surface and layers are not as good as other prints, but as a functional part it works okay. I can put them together without issues, and it also fits on the top gantry. I will try this out later. Next, I will start doing some multicolor prints. I will use Bamboo Studio to paint the color I need on the STL model. As this Gudetama model only has 3 colors, there's very minimal color switching, and the print will take just 2 hours. The model itself will use 19 grams of filament, and the flush filament when switching colors with the prime tower is 23 grams. So, I would try to print 4 of them, so the total printing time will increase from 2 hours to 4 hours, but this time, the filament for the model is 76 grams, and the wasted filament is still 23 grams, which makes me feel much better. I will just send it over the cloud. I will start with the stock setup and put the AMS on the table. When it's printing a single color, it just prints normally, but when more frequent color changes are required, you can see the print using more time for filament flushing than printing. When it's switching from black to yellow, it flushes away more filament than when switching from a light color to black, as it's making sure the darker color is flushed out completely from the nozzle. This is calculated automatically by the slicer. As you can see, when switching from white to black, it will only flush 196 mm³, but when switching from black to yellow, it will flush almost 4 times more. If you want to save some filaments, you can adjust the numbers manually or change the multiplier to 0.7 or 0.6, but I would rather keep the best print quality. The print took exactly 4 hours, and these guys are adorable. There is some stringing, but it should be easy to clean up, and printing multiple colors does generally string more than a single color print. Next, I will use the 3D printed mount to put the AMS on top of the gantry and redo the same print and see if we can see any quality difference. I will also recalibrate vibration and noise cancellation. After I put the AMS on the mount, I found that the weight distribution has a little problem. The weight is too much, and the machine is leaning to the back. When I zoom in closer, you can see the front of the machine is actually lifting up. Since this 3D printed mount is not the final version, I expect BambuLab will do some more fine-tuning for this model. But my quick fix is to just put 2 TPU pads at the back to balance it. Okay, the print took the same 4 hours. I don't see any issues, but let's compare them side by side. The one on the right was printed using the stock setup with the AMS on the table. I think the layer lines are still cleaner. From the side, the layers of the first print are also better, so the impact of putting the AMS on top is not huge, but I can spot some differences. Then, I will print a Hello Kitty with 4 colors. This time, the paint tool can't recognize the edges of the model as well as it could for the yellow Gudetama, so I have to manually fill in some gaps. It took me around 10 minutes to finish the painting. With more frequent color switching required, you can see the print time of this model is 12 hours. The model requires 48 grams of filament, so the wasted filament for flushing and for the prime tower is almost 5 times more than the model itself. So I will print 6 at a time to make a mini Hello Kitty army. The total print time is 19.5 hours, which is less than 3.5 hours for each kitty. The filament required for the models is 286 grams, and the wasted filament is around 222 grams. I feel more comfortable with these numbers because it at least prints more than what it wasted. The print finished in exactly 19 hours and 38 minutes. By the end of the print, 1 kitty fell off the bed and also ruined another kitty's hair a little bit. After some cleanup, the one with the ruined hair is okay, but the one missing the top is unusable. Let's check the weight of the models and flushed filament. The model used 277 grams, and the wasted filament is 235 grams, so it's pretty close to what the slicer estimated. As I didn't add support, some overhanging areas still require some simple cleanup, but the final results still look pretty good. In order to confirm the impact on the print, after putting the AMS on top of the gantry, I will use this setup to print another Benchy and compare it to the first one I printed with the single spool filament setup. It is still a 90-minute Benchy, but I think I can see some quality difference on the surface. Especially when looking from the side, the layer quality and ringing on these holes are pretty obvious. Finally, I will print a PLA sheet to test the auto Z offset and auto leveling. The print finishes in 30 minutes. Let's see how the whole layer looks. The nozzle is a little too close to the bed at the top area and the lower right corner. But it still looks pretty good at the back, and this first layer is not perfect, but it's definitely usable even for a large print using up the entire bed. Okay, let's talk about the pros and cons of this machine, starting with the pros. 1, it prints fast. It's not the fastest, but the speed is slightly above average among all new generation fast printers, and the quality of the 90-minute Benchy is one of the best, if not the best. For my other usual test prints, the print quality also stays above average. 2. Compared to the A1 Mini, it requires some more assembly, but it just takes around 20 minutes. And after that, the calibration and leveling are all done automatically, so it is still very beginner-friendly and easy to use. 3. The touchscreen interface is the same as the A1 Mini, and this screen interface is the best I have seen so far. The setup wizard shows the progress and some fancy graphics, which is much better than other machines that simply show calibrating, please wait, and freeze on the same screen for over 10 minutes. The menu structure also makes a lot of sense, and you don't really need to guess around to find the feature that you need. 4. The network printing workflow is easy to use. It takes just one click to send the job to the cloud. If you have any reason that you don't want your files to leave your local network, you can enable the LAN-only mode to print within your local Wi-Fi. 5. The Bamboo Studio Slicer is amazing. It's inherited all the good features from Prusa Slicer, and on top of that, it's added a lot of enhancements. Even Prusa Slicer brought some features from Bamboo Slicer back to Prusa Slicer, so obviously, when your competitor says you're good, you are really good. As a result, you can see the community loving the Orca Slicer, which is a fork of the Bamboo Studio. 6. It has a high-quality magnetic bed. It's better than all the magnetic sticker sheets commonly seen on most other printers, including the flagship X1 Carbon, but more on this in the cons section. Now for the cons. 1. Similar to the A1 Mini and other BambuLab machines, the biggest problem with the multiple filament single extruder machine is the filament waste. If you just print one model with frequent color changes, the amount of flush filament is a few times more than filament that you actually printed with. Of course, you can adjust the flushed volume or play with the multiplier to save 40 or even 50% of the wasted filament, but the print quality may not look as good as the default settings, especially when you have some dark to light filament switching. The ideal machine for printing multiple colors would use multiple tool heads, but printers like this include the Prusa XL with 5 tool heads, which costs $4,000, plus extra for the shipping and import tax. You can definitely save a lot of filaments and print multiple colors more efficiently, but the price difference is huge. 2. The bed leveling is totally usable, but it's not perfect. It works better than most printers out there, but since this is a BambuLab machine, I honestly expected more, like about the same result as the Prusa MK4, even though the A1 is priced much lower. I mentioned the same issue in the A1 Mini review video, but it seems the leveling still has room for improvement. 3. The bed temperature only reaches up to 80 degrees Celsius. Even though I can see the quality of the magnetic bed is much higher than printers that heat up to 100 or even 120 degrees Celsius. I believe BambuLab may assume using an open frame bed slinger to print ABS or other engineering grade materials is not ideal, but for users with some experience, they can work around this by using a thicker skirt as tall as the model to keep the ambient temperature to work with hard to print materials. So, limiting the maximum temperature of the bed may be a questionable choice, especially with the machine equipped with such a high quality magnetic bed. 4. Compared to the motion system with the A1 Mini, I honestly like the Mini more, as it's using linear rails on all axes. On the A1, it does use linear rails on the X-axis, but steel wheels on the Y-axis and linear rods on the dual Z-axis. The rods and steel wheels are still better than palm wheels, but I would prefer the X and Y axis both use linear rails like the Mini. The Z-axis using linear rods is fine, but on the Y-axis, the steel wheel setup with a closed base with gaps isn't great, and some filament residue may still drop in the gap. But it's not that big of a deal unless you try to pour all the filament poop into the gap and fill it up. 5. The AMS mount is a good idea, but since this is not the final 3D model and BambuLab is still fine-tuning it, the weight distribution causes the machine to lean backward. The extra weight and movement from the AMS will visibly impact the print surface unless a better version or solution is available, like mounting the AMS on a rack or on the wall. For now, if print quality is what you care about most, placing the AMS on the table and occupying some extra space may be the better option. In conclusion, the A1 is a larger version of the A1 Mini. They perform the same, with the same print speed, same print quality, and same limitation on the maximum bed temperature. The motion system of the A1 Mini is slightly better, but considering the price of this A1 is only $100 more and you get a 256mm³ print volume instead of the 180mm³ volume of the Mini, it's still a pretty good deal. Since the A1 is just about to release on the same date as this video release, I hope BambuLab has the option to just order the A1 instead of requiring you to order the AMS combo, as not everyone is a big fan of multiple color printing. As I've previously awarded the most advanced and the best value high-speed mini 3D printer titles to the A1 Mini, I don't want to award too many titles to the same brand, but still, brand is not a determining factor in my award decisions. So, I'm still going to present the title of most advanced high-speed regular-sized 3D printer to this A1. On that note, here's how our recommendation list works. We have 3 types of awards. The first type is the most advanced title, which requires the machine to showcase innovation and technological advancements ahead of others in the same class. The second type is best performance. Even if there is not much innovation, for the same price and with similar hardware, it must print better and faster than other machines in the same class. The last type is best value. This one is straightforward. The machine doesn't necessarily need innovation, but it should offer the same hardware at a lower price than similar machines, or include extra hardware at the same price. While it may not perform the best, it still achieves an above-average performance. Out of nearly 150 machines we reviewed, less than 10% make it to our recommendation list. If you are interested in our recommendation list and a 3D printer price tracker covering over 100 popular machines with spec comparisons, please visit AuroraTechChannel.com. Additionally, you can find the link to the BambuLab A1 in the description. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching and I will see you next time.